Yo, what's going on, guys? Rhys here from Stoic Pool. And in this video, we're going to be talking with PG about his Catalyst proposal, Deepchain ADA. And we're going to talk about AI training and machine learning on the blockchain. It's going to be super interesting. I'm so excited about this. As I was saying, hey, PG, by the way, hey, man, I'm just going to talk for a sec. So sorry in advance. But I know PG from like a load of different places, like the Armada Alliance, Singularity Net Community. It just seems to be everywhere that I'm in, like New Net and stuff like that. Like you're just involved in all this stuff. And so like, I feel like I already know you quite well, or like what you're interested in. And it's really nice just to be able to put a face to the name, really, a face to your avatar.
Yeah. Sure.
I've learned a lot from your YouTube videos.
Oh, thank you.
A lot of it went straight over my head, but I learned a lot still.
Yeah, I still try to keep it, try to dumb it down, but sometimes it's a little difficult. Then I do have something like a K-bit series where I go to some more basics, like not really about anything about deep learning or any of that. But yeah, let's see how far and long I can do that.
Well, the other thing as well that you're that I think I see a lot of from you is your Haskell Twitter.
Oh yeah,
I think that whole thing. How many days have you been going for now? It's like 79 or 80, isn't it?
I think today it was 82 or something on Haskell, and on zero knowledge proofs, it's probably 22 days now.
Yeah, I think something like that.
Yeah. Well, Twitter is a little funny. I mean, I started in all this social media space after I started the PGWAD pool, because that's the only way you can reach out to people. I mean, unlike an Ethereum miner, you just don't put a hardware and then you say, okay, I'm going to forge blocks now. But here you need to reach out to the community. And I always thought that, Twitter is full of trolls.
Yeah.
So you post something and then people will be back at you and things like that. But after I joined Twitter and Cardano community and now I'm attending sometimes some Twitter spaces also. So it's really fun in the sense that the community is really good. People don't really get back at you with trolling and all of that. At least I have been spared from that.
I think a lot of that, right, is because you come from a position where you have a deep understanding of everything that's going on. You understand what you're talking about a lot, whereas a lot of people, especially in like crypto Twitter, are just a bunch of guys who bought some stuff and is waiting for it to make them rich, so they kind of just troll each other a lot of the time, and you just sit back and bring the knowledge. So it's a bit, you come from a different angle. So I think you're kind of just spared from a lot of the drama, basically, which is a good thing, because you don't need it.
Yeah. But sometimes, it is funny. You do get excited about certain things, and then suddenly you realize that you are that troll. So to keep myself under check, and what I said is that, okay, every day morning, if I open the Twitter, then I should put out a tweet saying, okay, something about Haskell, right? Because the notion around Haskell is that it's a very tough language, or something which is very difficult to understand, or something like that. Which I want to say that no, it's not really that. It's all about functional programming. So if you understand functional programming, then getting Haskell is easy. So then usually people start up with from Learn Your Haskell book, which is good. But my recommendation is Programming with Haskell. That's a very nice book because Learn Your Haskell is good for, if you're coming from, say, a Python background or any of this imperative language background, and you want to quickly do something with Haskell. Because usually a programmer, when you're given a new language, you just want to try out certain things. The usual stuff that you do in your regular language, you want to do that in this new language. And that's a good starting point for Learn Your Haskell. But Programming with Haskell starts from basics. What is functional programming? People ask lambda calculus. I mean, do you really need to know lambda calculus? I mean, it goes from there, and then it tries to demystify a bunch of things. Then there is another book I refer, which is called as a Practical Haskell, where they talk about some practical implementation, how there are certain things that you can do with Haskell from an academic perspective, but there are many things you can do from a practicality part of it. So there are some tips and tricks that brings. Then there is another book which I highly read these days is Haskell in Depth. So there it talks about things like how Haskell stores the data, what are the compiler optimizations, and how GHC does these optimizations, and what you should know about it, and things like that. These are very good if you are writing a code and you want to optimize it for memory, or you want to parallelize your application and things like that. Or just if you want to go and understand some of the Haskell code that is there in the Cardano ecosystem, then this book is highly recommended. I mean, there are certain things they have done it in certain ways, why they did it that way. That kind of answers this. So what I'm doing right now is, I'm taking excerpts from these books, which I find interesting, and then I make a daily tweet out of it. So the idea is not to really give a Haskell training or anything like that. The idea is just to ignite an interest into Haskell. So if you follow the Twitter thread, then it goes right from very basic till, so today I gave about what are closures and how closures are represented in the memory and things like that. So yeah, it goes, keeps growing in that order. And the zero knowledge proof is something I started very recently.
Because it was just before Christmas, wasn't it?
Yeah,
you started that like beginning of December or something.
Yeah, I was doing a lot of things for the Deepchain ADA project. So Deepchain ADA uses a lot of these advanced cryptography techniques, and in that, for auditability, I had to use zero knowledge proofs. So then I just tweeted out saying that, hey, anybody is interested in understanding this zero knowledge proof? Then a couple of guys responded back to me, said, yeah, why don't you start that? So I started with basics of zero knowledge proofs, then what are commitments, then Peterson commitments, and then it's growing. I mean, you can think of me as a selfish guy. I'm not really giving out things. It's personally for me. When I wake up and open Twitter, I have something on the back of my mind saying that, hey, you need to give 2 tweets today, one on Haskell, one on zero knowledge proof. So that keeps you focused on, what should I tweet? And it should be like related to the previous tweet. It cannot be like something random out of the air, so that if someone is following the thread, they can
creates almost like a journey into Haskell.
Yeah, something like that.
Or zero knowledge, obviously.
Yeah.
I find, just so you've already spoken about so much, like I love it. I feel like I could just sit here and listen to you, because this is something that I've only really got so interested in because of getting involved in Cardano. And I find that a lot of people who are involved in Cardano are like, yeah, I'm learning Haskell, and I feel like it's kind of, I'm learning about programming, like computer programming, because of my involvement in Cardano. And I've got the Haskell book, I think it's the first one you mentioned.
Yeah.
And
Learn
so
your Haskell. Yeah.
No, not Learn Your Haskell. So that's like a free kind of program essentially that's just on their website. But this is one that a book that I purchased, the one that covers what functional programming is, and then what lambda calculus is, and like the second one that you were talking about. So I've got that book. And it's a pretty heavy read, you know. And one thing I found from learning to code, because learning languages just generally, coming from a guy who doesn't have a lot of experience in programming, learning languages, at least when you learn like Spanish or like French or whatever, you know, Gujarati or whatever you want to learn, like there's always a purpose in your head, like what you're going to use the language for. But with computer programming, I have no idea what I'm going to use it for yet. It's just like a whole new thing. I'm just learning loads of stuff, you know, and like it's like hard to imagine how to apply it, you know, whereas like a language is kind of obvious. You're going to use it to converse with people, you're going to use it to ask things. But it's really it's been a whole process of like changing my kind of thinking of how to apply something that I'm learning. And it's just maddening, you know, it's maddening. Yeah. But I love it. I really enjoy it. And, you know, I'm getting there slowly because there's so much stuff going on as well. Like, it's hard to do it. And I'm not learning it expecting to build stuff straight away. I'm learning it so that I can communicate with other people who are much smarter than me and know much more about it, so that I can at least chat on their level and understand what they're saying to me a little bit, you know, and then maybe one day I'll build something myself. But I think it's just fascinating. And I feel like I could just listen to you chat about it for ages. So if you need to go and just chat about stuff, like, you carry on. I'm not going to interrupt you. But Deepchain ADA. Yeah. So Deepchain ADA is your catalyst proposal.
Yeah.
So do you want to kind of introduce that and talk to us a little bit about that and explain what that is?
Yeah. So the Deepchain ADA was something that I started thinking about almost a year back. I was trying to understand. So the whole idea is that whenever you do a machine learning algorithm and you want to train that model, then you need data, especially in a deep learning kind of a situation. You need lots of data. And
like the more data you have, the better the algorithm
can be. And when we study in university and basically if you are doing any course, then you have a lot of you never worry about the data part of it. You look mainly at the algorithm, and then you say, okay, you have 10,000 images or whatever, and then you say, this is my training set and this is my validation set, and then you're done with it. So I did my machine learning course from Arizona State University. So that was something. So I'm basically electronics engineer, and I picked up machine learning in 2014, and
just casually.
So I had these GPUs, and then there was a famous paper on AlexNet, which said that now you can use GPUs for GPUs with a deep neural network. You could get images, right? I mean, identify objects in that image, and with a GPU. So that kind of revolutionized the whole AI space, because until then the algorithms were there. Some of these are very old algorithms. It's not like they're new or something like that, but it was just scaled by compute, in the sense that because the compute was not really up there, you couldn't
do it at home.
Home. And that's when I started trying to understand. And then there's a famous course in Coursera by Andrew Ng on machine learning. So I did that. Then I wanted a little more rigor and do project and things like that. So I joined the Arizona State University program for machine learning. So I did my course there, and then I started investing my time in this space. And fortunately, my day job involves designing chips around machine learning and AI space, because almost everyone is entering now in that space. So it kind of gives me a nice opportunity to explore some of these algorithms. So that's where I started investing my time in this machine learning space. And one of the personal projects that I wanted to do now, you learned you did the course, and now you did the projects in that course. So now you're raring to go and see if you can do some real world problems, right? And then one of the things that I picked up was on lung cancer. So I wanted to understand, can we do something about detecting lung cancer and things like that. Yeah. And that's where I hit a big bottleneck. Nobody's ready to share the data. People cannot just share the data, just like how I have like 10,000 images and then I train my algorithm. Suddenly you cannot. And then that's when you need to collaborate with a healthcare provider and things like that. So I work with some of my friends who are in the medical field, and then we had to go through a lot of paperwork and say that this is only for research purpose. It is not for commercial and all of that. And it took me about 6 to 8 months to just get access to the data. And then the data that you get is completely different. When you're working in a university as a student, you have this very nice set of data. It's all trimmed and it's polished, and you just focus on the algorithm. So I was grappling with all of this, and then COVID-19 happened, and I was very curious to understand, are there any researchers working in this space, machine learning space, who are contributing towards the COVID-19 side of the things? Of course, there were a lot of researchers. I think 420 odd papers were published, but there was one common problem with all of that. They didn't have a full representative set of data. It is they probably had some limited data, and they worked with that. What happens is, whenever you have this kind of a situation, the model gets biased. So to give you an example, say if you take a child, and then when we were kids, usually my mother wouldn't work. Like it's the father who is working, and then mother who is cooking, right? So and if you are always taught in that kind of an environment, then you develop that bias. You think that women should cook and men should work, so which is not really true, right? So the world is not that way.
It's not that that's right or wrong, but it's that you've been exposed to throughout your life. So that's just how you naturally think, because it's how you compare things to your past experience.
And very similar things happen to these models. If you train them in like
a certain demographic or data set,
then it becomes a challenge. So there is a lot of bias that gets developed around that algorithm, and that's where a wide variety of data is needed. And then what I found was that there were 10 pharmaceutical companies who collaborated, right from AstraZeneca to a bunch of things. It was a European project where 10 of those pharmaceutical companies collaborated, and they used what they call as a federated learning. So federated learning was something that was pioneered by Google. And basically, they want to collect data from your phones, right? But they don't want to expose the information, or they want to maintain the privacy of your data and still want to extract the metadata out of that and things like that. So what happens is the model gets trained individually across these multiple parties, and after each round of training, there is something called like an aggregation. So this aggregation is done by a central server, and then the updated model is again sent back to all these guys. So over the period of time, the model will refine, and then it gives you now the model is better trained. So there is also something called as a multi-path learning, in the sense that in case of this project where the 10 pharmaceutical companies collaborated, each one was doing for a different set. They wanted the same data, but the end result was a little different. So their last few layers in a deep neural network were different for these guys. So it also helped in such kind of multi-path path learning. So my question was that, okay, the big tech and the big guys can do it. What about an independent researcher? I mean, I'm not affiliated to any university or any of that, right? So I cannot get access to that that kind of infrastructure.
Or just any data sets that you might want as well, because you don't have, you're just a person. You're not like a university has a bit more clout when they're trying to get hold of some data, because you think, well, they will be researching stuff, but it might be more difficult for you, especially like private data, like healthcare and stuff like that. It'd be a lot more difficult to get your hands on, of course.
Yeah. And that's when the other problem is that if you're an independent researcher, then you write your algorithm, then even if you get it trained, nobody will buy it. You just have to give it for free in a GitHub, or in fact, you'll have to probably plead people to use it, because I mean, how will they know you're not stealing their data? Because these models can be very shrewd also. This is one of the things I talk in my Deepchain ADA talks also, that you can snapshot and take and steal data using these kind of models. So people will not trust you. That's where I found SingularityNET. So SingularityNET, I would say it's a multi-headed entity. I mean, SingularityNET marketplace is what is AGIX, but they have a whole, as you know, a whole research of the true AGI and all of that. But I was interested in the marketplace kind of a thing, because now you could put your model in that environment. Probably you don't want to charge anything. You just want people to use it. Then because SingularityNET now gives you that kind of an environment where you can put your model. They have something like a rating system. So if your model gets used and if your model is good enough, they give you a reputation or a rank, and that's a good thing, because now you're building trust over time, and there is a place for your model. So then I started thinking, after this COVID-19 thing, and what the big guys were doing, why can't we do this in a trustless environment? That's how I started thinking about this problem. So in a federated learning, you have a central server, you have multiple parties, you trust this central party. Say maybe it's a Google or someone, and then you train your model, and usually this central entity has more say in that kind of an environment. So can we do a trustless thing? That was the question I started with sometime in 2019 and early 2020, and I started first looking at Algorand. So Algorand is usually, because of its history around cryptography and the founder and all of that, I started looking at Algorand, but and then I saw the video of Charles Hoskinson and Ben on the SingularityNET plus Cardano. So I slowly started getting interested in Cardano, because I wanted to do something. Whatever I do, it has to get into SingularityNet, right? So that's what I started moving towards Cardano. And then I found that in Algorand, you just can't really start a relay. It's permissioned system when it comes to some of that. Only certain universities and the Algorand Foundation runs those relays, and you cannot. I don't know. You can't
just start spinning up Algorand nodes. You mean?
Yeah. I don't know now, but this was
at the
couple of years back. Yeah, and then I started investing my time in Cardano, and then my experience with blockchain has been with Bitcoin. So I started with I used to work on designing Bitcoin ASICs. So in early
designing the ASIC miners.
Yeah, and then I lost interest in that. I don't know why, but I kind of it was a cool technology to work on. Blockchain was. We studied distributed systems, and in distributed systems, it was always the thing that it can only be Byzantine fault tolerant, wherein you need a 2/3 majority of honest players. And why do you want to do it? If it's a trusted system, then you don't need any of this. And now suddenly there is a trustless system and it's working, and I wanted to enter Bitcoin, and then from a technology aspect of it. But yeah, I kind of lost interest in that, and probably because I started investing more time in this machine learning thing.
You think something that came up that kind of interested you, it only lasts a certain amount of time, and then something fresh came up and you thought, ooh, dip your toes in that. And then machine learning's just kind of taken you away.
And at that time, I didn't know how to what is the use case of Bitcoin. I mean, I understood the peer-to-peer network. I understood that we want to have a trustless environment, but I couldn't grasp how will it solve the problem. I mean, fine, it's a P2P network, but will it really solve the problem? And then at that time, Bitcoin became very notorious amongst all the illegal activities and things like that. And I was always wondering, I mean, how come these guys think they can get away with it? Because everything is registered in the blockchain. If you can map it, you're done. It's not like, but yeah, I couldn't find application for which I am interested in to go around that. So I was trying to see what we can build with it, but machine learning kind of was the wave at that time, and yeah, you had to learn it, kind of a thing. So so that's when I started investing more time. But yeah, SingularityNET showed the use cases of a decentralized market, so that sparked more interest. And then I started learning Cardano, and yeah, I read one paper after the other, all the Ouroboros papers, all the networking layer, and all of that. And then I was saying, oh, this is great. So then Berry Pool. So Berry Pool came up with a Git page saying that, hey, I'm running Cardano node on a Raspberry Pi. I said, damn it, I should do it.
Yeah.
So that's when I started a Raspberry Pi node. Then I built a pool. Then I thought, although being a developer on Cardano, you don't really need to start a stake pool, but starting that stake pool is, it's exciting. I mean, there is some, I don't know, I cannot express it in words, but there is something. It's, and you come from that Bitcoin kind of a world where you needed a simple computer, and then you move to these gigantic machines and miners and things like that. And here you can run it on a Raspberry Pi mobile chip.
You know what? Actually, right, those mobile ones, that blew my mind. I saw that today, and I was like, what? Yeah. Because when I first heard about the Pis, I tried to just set up a Pi using the normal Cardano binaries, like the normal 86 binaries. And obviously it doesn't work. Like it just didn't happen. And so I was like, oh, well, that was disappointing, and then forgot about it. But when I was first like learning about that, because I went straight for cloud service when I started for the first kind of year, really. I always liked the idea of being able to have a node with me the whole time, And so when I saw those mobile ones, I was like, oh my God, my prayers have been answered. I couldn't believe it. Some of the stuff that people are actually doing is amazing. It's absolutely amazing. I think it's fantastic. I have chats with people about the Raspberry Pi node thing all the time, because it kind of bewilders me how it even works as well. But so many stake pool operators think that it's not a good idea, and I'm like, it doesn't matter.
Yeah,
why does it matter?
I'm just running it because it's fun. It's fun running it. I mean, I want to see when it will stop working. That's my goal. I mean, I want to see when IOHK will pull the plug and say that you should not run on Raspberry Pi. So
yeah, but I don't think that some pool operators think that running Cardano on a Raspberry Pi is a bad idea. I don't understand why it's a bad idea. Being able to do something on something so powerful and such a small bit of kit, like surely that helps decentralization. It doesn't like create problems, but people's opinions are different, but it's bewildering to me. Like I love it.
I just say, I just talk about this decentralized mind, right? I mean, not deep mind, decentralized mind. So the decentralization should start from our thinking. Can we solve the problem? Are we allowed to solve the problem? So if you are not allowed to solve the problem, then I say the work starts from there. You should get yourself to a position in the system such that you are allowed to contribute, right? I don't have any grudge against people telling me not to run on a Pi or any of that.
Me
Yeah.
neither, but I hear it a lot. I do hear it a lot.
Yeah. It's. I would say that fine. I mean, you think you have to run it on a high-end server? Great, run it, because the ecosystem needs all kind of players, right? So
Yeah.
decentralization is not just on the stake. Decentralization is on the stake. It's on the hardware. It's on the software.
Yeah.
So
it's on block production. It's on node distribution. It's on. It's layers. It's layers.
Yeah.
You're absolutely right.
And so, I will not stop you from investing $300K in a hardware. You don't stop me from investing $200 on a Raspberry Pi. So, and in the end, I mean, Armada Alliance. The good part in Armada Alliance is that it's like a cohort, right? That each one validates the other, in the sense that we know whenever a new node version comes, we know if it will work, it will not work. If it will not work, then what we need to do. So people are active on the test nets. It's not like, PGWAD woke up one day and said, "Oh, I'm going to run it on a Pi and build it, run it, and that's it, and that's it." Yeah, it's a continuous process. So, and it's not like I have a Pi and then I'm done with it. A good operator also has backups. So if your Pi breaks one day, then what are you going to do? Are you going to replace it with one more Pi, or are you going to replace it with one more different device or something like that? So I think the stake pool operation is a whole different ball game, I would say. It's not black and white that you have to do it this way. No, I don't think. I think it's that's where the personalization comes into picture, right? I mean, you build a cool Pi node with the water circulation and water cooling and all of that. I mean, people may ask, "Hey, why are you doing that?" But I don't want to ask that. I was so thrilled. I said, "Yeah, here is a guy who wanted to build it, and he built it, and it's working." So, and in the process, you found some things which are not working. Great. So you went and fixed it, right? And that kind of zing is something some people will never understand.
I agree. And like, obviously the water cooled thing is it's his own ball game. And it was something that personally I just did because I really like the idea of doing it. It felt fun. That's where it came from. It just felt like a fun project, something that I wanted to do and I wanted to try. And we had a leak, so it wasn't perfect at first, but we stayed up late and we fixed it, and we solved it and we worked it out. And I think that, like you say, that's a big mentality around the Armada, that Armada Alliance. By the way, guys, for those who don't know, check out the Armada Alliance, because they're like some of the guys in. I just admire loads of the people in that group, because like you're saying, everyone's working on testing everything to make sure it works, seeing what they can do to get it to function. And it's a very active community. Some communities that I know from Cardano are very passive, whereas the Armada, there's always conversation. Everyone's collaborating together, everyone's working together, everyone's helping each other and testing stuff and trying to solve problems for each other. And it's such an inclusive and positive atmosphere. I love it. I think it's great.
Yeah. And I always tell that to the Armada Alliance guys that, I have been a big beneficiary of Armada Alliance.
Me too.
When I wanted to start, so I had this. So when I started the pool, then I said, okay, let me start. I started thinking about the Deepchain ADA part of it, but then I also wanted to build some educational videos around it.
Yeah.
And then talking with the guys, I figured out, okay, why shouldn't I do a blockchain plus AI course kind of a thing, video series? And Weil gave me an idea that, hey, why don't you do a Git book on Armada Alliance? You can, whatever you talk in the video, you put in the Git book. I kind of liked it because some people like to see the videos, some people like to read about it. So yeah, and I got the space there, and I just started creating the Git book. So I think I finished the blockchain part of that, and now I'm starting the deep learning part of it. So I'm excited about that. It's a very constructive environment. So in general, that's what I find in Cardano community. I'm also part of the XSPO Alliance. So it's a very constructive environment. People throw ideas, they give you ideas, they validate you, and in the sense that they ask you tough questions, and are you
they stress test your ideas, don't they? So I get that in the I see that happening in a handful of communities. One that I always say is very good for that is NASEX Discord. Armada and NASEX Discord, like these are the two things that I promote, like the two communities that I really love, and I'm really grateful to be a part of. They have stress test all of my DAO ideas, as well as some of the Armada guys, and it's those two communities that I've shared the development and my thinking around the DAO the whole way through, because those are two places I know I'll get support, but I'll get kind of critical support where they'll stress test my ideas, they'll poke holes, they'll try and go, well, what have you thought about this? Have you thought about this? And it can, from the outside, it can seem like they're just like shutting it down, but actually they're trying to help you think better about your ideas and help you develop them and improve it and kind of, it just matters so much to like these people, you know, and it's amazing. It's amazing. And the XSPO guys, like you were saying, I had a chat with them Sunday. Yeah, it was Sunday.
Sunday.
And again, they like it was talking about the DAO, but they were asking loads of questions. They were asking the technical information about it and stuff like that. They wanted to understand how the different parts and the different processes and the mechanics of the DAO were going to work, and had I thought about this, and had I thought about how this would be implemented, and how people can exploit it and stuff like that. And it really gives you good feedback, you know, because a lot of people go, oh yeah, that's a great idea. And that's it, you know. But like these guys, they try and prove you wrong to help you make it better, you know. And that's really in a positive way, which is fantastic.
So that's when I started with the Deepchain ADA project, and the idea was that basically decentralize this federated learning, and once you have a trustless environment, then you have to start thinking more about. Sorry, okay. I think I got dropped, and
you got too excited and it messed with the network.
So what I was saying is that once you have the trustless environment, you have to start thinking about privacy and auditability. Now, usually in a blockchain kind of an environment, what happens is the auditability and is kind of guaranteed, because you can go and check the blockchain ledger, right? So that's the auditability part of it, and privacy is mainly ensured through your things like that. So
I missed that. Sorry, the privacy is kind of included through.
It's included through your public key, in the sense random public key that you generate and things like that. Although,
which is basically the cryptographic kind of fundamentals of the blockchain.
Yeah, but something like a proof of stake, it's a little difficult because the delegation address can kind of leak your information.
Yeah.
But in general, we are not too bothered about that. We want to ensure that we want to transfer an asset from A to B, and we want that to be auditable, right? That's the goal of the blockchain. But when it comes to Deepchain ADA, then what we are doing is when you train these deep neural network models, there is something called as a backpropagation, where you go through the front path, and then you see what is the error. Like if this expected was A and you got an A prime, then you know there is an error. Then you backpropagate all the way through all the layers, and these what we call as the parameters or the model parameters get updated based on this what we call as the gradient.
So it's like feedback, basically.
Yeah, it's like
it's
a
feedback and then adjustments based on the information that's returned.
Yeah. So usually what happens is that in a federated learning, these gradients from these various parties are shared with the parameter server, the central server. So the idea is you are not sharing the data, but you're sharing only these gradients. So it should be harmless, right? Yeah. But what papers have shown is that you can do things like inference attacks and membership attacks by just using these gradients.
Wow.
So Apple uses something called as differential privacy. They were pioneers of differential privacy. So differential privacy is something like, say you have your identity card, you just blur your name and some information, and then but they have your date of birth and they have
the rest doesn't really matter because non-identified.
Yeah, what there was a famous article or paper where people could go back to a governor and say this medical data belongs to this governor.
Wow.
They were using some kind of differential privacy. So the differential privacy, what it says is that you introduce noise along with the data so that it's not fully, cognizable to a third party. But people have ways around it. So if you have enough data, enough metadata, I think I probably dropped for a few seconds or something.
No, I don't think so. Okay. But yeah, if you had enough of the metadata, you could basically use that.
Yeah, you can do something called as inference attacks and membership attacks. So that's where you cannot send these gradients in their raw format. So anytime you want privacy, the encryption comes into picture. So now when you encrypt these gradients now and you send it to a central server, or in our case, we don't really send it to a central server. So we have another additional challenge, right? Because this particular, whoever gets chosen as a slot leader will go and do this data aggregation kind of a thing, or the aggregated data, they put it back in the blockchain, which all others can take and update their model. So now the thing is, we have to encrypt this, and when we aggregate, we should be able to aggregate the data using these encrypted gradients. We should not decrypt it. Like, for example, the slot leader should not decrypt it. He should take these gradients, get them together, and in the encrypted form, and he gives the sum in the encrypted form back to all the guys. So this is called as homomorphic encryption. So homomorphic encryption, what happens is, say you encrypted A and B, or say, for example, you encrypted 8 and 10, and then you do an addition of that. So in the encrypted form, when you decrypt that addition, you will get 18.
So which is amazing, isn't it? Like, how does that even work, right? That's crazy.
That's the whole thing about the homomorphic encryption. So Deepchain ADA uses that homomorphic encryption for this. And now the thing is, there can be malicious parties in this environment, right? So if the party gets that encrypted summation, then they can run away with it.
Okay.
And so what we do is we do something called as a threshold decryption. So instead of one guy being able to decrypt that, you need a certain set of number of parties to work collaboratively to decrypt that. That thing. So that way, only one person cannot run away with the data.
So it's almost like you need, instead of just like me being able to decrypt the data, I would need me and you to work together to do that calculation.
Yeah, and we can set. So for example, if there are 10 parties who are training, then at least if 6 of them can collaborate, then you know that the whole system is honest. So I always talk about this trustability and honesty. They are not the same. So
no, but you know what? They kind of for it to be automated and trustless, they need to coexist and they need to both rely on each other to implement. Because otherwise there can always be someone acting in being naughty, and that's what you need to mitigate for it to be be able to trust it entirely.
So if we assume trust, then I don't have to do any of this because I trust the party. But here I only trust the honesty part of it. So what I say is that in this given set, majority of them are honest. There are some Byzantine actors, but majority of them are honest. So the threshold decryption kind of helps you with that. Now we can do with all of this like a number, like you have 10 parties, 6 of them, if they collaborate, great. Then I started looking at the paper from IOHK on Mithril, which is stake-based multi-party computing, wherein they also introduce stake into the system. Say it's not just threshold stuff, but who are those people? I mean, if there are 10 parties and 6 of them are not really contributing to it, but they collaborate, then it kind of beats the purpose. So I'm now thinking, okay, can we do stake-based threshold decryption? So instead of 6 parties, I say that 50% of the stake should be present. So that way, even if there are 6 parties who are just having only 40% of the stake, they will need one more for that. But it's
so
a little.
What that introduces then is the aspect of community trust as an extra layer to the consensus, right?
So, and in this, the stake cannot be really like an ADA or something like that, because, what happens, what we need is a different kind of stake mechanism, in the sense, amount of data they are providing for the training, or and there are various aspects around that. For my initial work, I'm not really looking at stake-based decryption. But I want to design it in such a way that later, if I want to introduce a stake-based decryption, I can easily map that. So this kind of ensures that we have ensured trustless environment with the blockchain. We have ensured privacy with all these cryptographic techniques. Now there are what we call as honest but curious players, so or lazy participants. So they are good for, so this training say happens for 10 cycles. They are good for 6 cycles, and from 7, 8, 9, 10, they are kind of lazy. They don't want to do the training, right?
Yeah.
Because this involves a lot of hardware and things like that. So they may just be free riders. So how do we catch those free riders? Very difficult, because they are sending encrypted gradients. So you don't know what they are trying to do. So this is where auditability comes into picture. So whenever they are doing this compute and the gradient, they submit a zero knowledge proof. They submit a proof of their computation saying that I have done the compute and here is the proof. And this has to be non-interactive. So there are interactive proofs and non-interactive proofs. So interactive proofs, it's something like, I ask you a question, you give me an answer. I ask you another question, you give me an answer, and then I'm satisfied that you have done the work. In a non-interactive case, then you have submitted all your answers, and I have to go and check it. So it's something like, in school, at least in India where I studied, when we were kids, the teacher would first ask you questions and you have to answer in front of her, and then you would get a paper, and then you would write that. So that question and answer is like the interactive part, but what you write and submit is the non-interactive part, because then the teacher checks it. So that's the simple version of this.
Thing. I think that's a very relatable example as well.
Yeah. So and the other part is zero knowledge, because we don't want to leak the information for whatever the party has done to these third parties, right? So and non-interactive, because there can be an external entity. It can be like, you can, if they're really working on a high confidential data and things like that, they can appoint an auditor who is not part of the training, but they can still verify that the training happened in an honest manner. So this is where I use zero knowledge proof. Some of the zero knowledge proof will need what we call as a trusted setup. So you have to trust a party to do some of these to generate certain parameters for the zero knowledge. Now we want to be completely trustless, so there is a paper on how to do this in a trustless kind of an environment, even for the initial setup. So yeah, this there's a lot of this cryptography and zero knowledge proof that gets into the Deepchain ADA layer, along with the smart contracts part of it.
Well, yeah, I mean, it just tackling that the trustless aspect of it automatically adds so many layers of complexity that you need to kind of be considerate of, especially if you're dealing with like very private data.
Yeah. And that's the best part with Cardano, right? So Cardano has the Cardano settlement layer and the computation layer. So all of this will fall in that upper layer of computation, and in the settlement layer, you only have these proofs and encrypted gradients that are there in the blockchain, so that not only today, 6 months down the line, people can still go back, check whether the training happened properly or not. And if the model has not performed, then you can do some things like, why it did not perform. Was there some lack of data or something like that? So this is where the Deepchain ADA, the core of Deepchain ADA is, I would say. And then it starts working with Singularity Net. we can train the model, then put it in the marketplace, and then it can interact with the other agents, AI agents, and things like that. That's where I'm trying to see about the AI DSL space also, as part of the Singularity Net. And then NewNet comes into picture because if you have the data but don't have the compute, or you don't want
the work
to use,
done,
then NewNet comes into that.
And I think this is somewhere where the Deepchain ADA, the kind of trustless training, matches so well, because NewNet is basically perfectly positioned to function from your proposal, isn't it? Like having that trustless training mechanism means you can distribute it across computers all over the world, and it doesn't matter that it could be here or it could be there, because it within the mechanism is all proven to be safe and secure, and that it requires so much of everything to be collaborating together to be proven and to be shown, you know. So I think the concepts here and how they kind of fit together, and then just like NewNet turning up is like perfect. It's absolutely perfect.
It's so once NewNet started, I jumped in and I said, cool, this is something which solves this is the true trustless decentralized environment in the sense.
Absolutely.
And as part of the proposal, what I'm asking is for $20,000 for the cost of the hardware.
Just for Raspberry Pis.
No. So this one is for, so I'm building, I have to build these desktops which can do the machine learning algorithms. So, and then there are other challenges, right? In the sense that, can it do only simple algorithms, or can it do a little more complex algorithms? So you need a little higher end machine with like 2 or more GPUs and things like that. Will it scale as we increase the complexity of the algorithm? So those are some of the testing that I want to do. I was asked a question that, why don't you use like a Google Cloud or Oracle Cloud or something like that? So I went back and I said, maybe I'm asking $20,000, and why I did not give a comparison of how it would do on a cloud. So for the kind of system that I want, it was turning out to be like per annum, Google Cloud was way expensive because they have higher end GPUs. I don't need those kind of GPUs for this experiment. Oracle Cloud was the cheapest with about $6,000 per machine. My estimate is $8,000 per machine for the desktop that I'm trying to build. Oracle Cloud was $6,000, assuming that you are using 50% of the time, in the sense it's not on 24 hours a day. It's probably on like 6 to 8 hours a day.
So you're just switching it on and off, and
and
which is kind of inefficient, isn't it?
It's and it's I would say you're burning your money. I mean, at the end of 1 year, you neither have the computer
nor have the work, really.
You have to move all your work again back into your own system, or you have to move it to another cloud, or pay
more
for the next year.
And I think something like this is where bare metal really shows its strength.
And then now NewNet is going to come up with the GPU support and all of that, right? And NewNet has this concept of volunteer computing, wherein you're not really earning tokens, but you're giving it for volunteer work. So I said that this particular setup can be used for NewNet testing also as part of volunteer computing. And I have a project around volunteer computing, so I can reuse the same hardware in that. And it can run 24/7. it can be used by the Deepchain ADA project, and it can also be used for NewNet. So I can, and we can do all these kind of settings with NewNet, right? Like NewNet has this option that you want to give the compute only for certain times and things like that. So all those kind of testing we can kind of do in this.
And again, NewNet then becomes a really good environment to apply what you're trying to build and what you're trying to test, because NewNet automatically assumes that people use it. People will supply computation, they'll turn their computer off. They'll leave it on overnight one day, it'll be on sometimes, it'll be off sometimes. And it needs to be able to balance the load when stuff comes in and stuff comes out of the network and resources become available. Yeah.
So this is how we are trying to build this system. And I have a timeline of 1 year to showcase this kind of an application. And I think it's a continuous process. And as part of this, I'm trying to do something else also, like why not use Haskell in machine learning? So there is a Hask Torch, which is a deep learning framework. Just like how Python has PyTorch, there is a Hask Torch. It uses the same.
Yeah, which you were talking about in the Armada group today, right? You were talking about you trying to get that working on the Pis.
Yeah, not the Pis, but on my Mac M1.
Oh, sorry, the M1. Sorry.
Yeah.
Man, there's so much conversation in there. It's hard to keep track sometimes.
Yeah, and it runs perfectly fine on an x86 machine with a GPU, which is the intended use in my case. But I just out of curiosity, because I do some things on the M1 also, I ran the Plutus Playground on M1 and all of that. So I wanted to see if I can run this guy on M1. So those are,
again, it's decentralization of resources that way, isn't it? If you can have something running on the ARM architecture and on the x86, then you just automatically have more resources available to you.
Yeah. So those are some of the things that I'm working on as part of the Deepchain ADA project.
Yeah, so it's a very experimental kind of project to try and figure out how you can basically apply these concepts as a complete entity, introduce all these concepts to create a kind of trustless, decentralized machine learning platform, essentially. And test how that works. I think work like this, like a lot of people see Catalyst as like, I want to build an exchange, or I want to build a game or something like that. And there are some projects now that are really about this kind of R&D style funding. And I think there needs to be more of it. I think that getting this work out and getting stuff like this as the going example is really important for doing work that otherwise is very difficult to do, especially by yourself. Like you're saying. The thing about going with universities for research is that they have their own biases towards certain types of work because of what they can get funded for. And having an inclusive environment in Cardano where we're funding people to choose what kind of work they want to do, and then we choose how they get funded. I think that is and for the fact that obviously it's working within the ecosystem means that you can do potentially some very good work, like great work in off the back of Catalyst, which is important. It's important to get these systems working so that they can be applied. And just talking about this, things have come out just over the 2 years or so that you've been thinking about these concepts and how they can work. You've been exposed to Singularity Net, and then you've been exposed to the Singularity Net spin-offs, which are already trying to implement these things like Rejuve, like NewNet for the computation and stuff. And really you're just trying to figure out how to use them all properly and use them in a way that makes it worth having and actually applies the technology and those concepts together, which is it's fantastic. I love it. I think it's one of those things I don't know a lot about, but I can see what it would be good for. I can see why we would need to use it. And it just fascinates me. Like, I'm just sitting here listening to you. Like, I'm not even interested in saying a lot of stuff, because I just like listening to you tell me all this, and how the journey of where it all comes from and what you're trying to do. It's amazing.
I think that the AI bias is for real. We see that even in some of the social media platforms, right? People just get blocked because the algorithm thought they were doing something, which was
it's not based on real analysis. Like a human analyzing it would come up with a completely different result, and generally not blocking someone, whereas because of how it's used, and that's just in kind of that's just moderating social media, but then you also have the marketing of social media as well, and the way that AI is used, the machine learning is used in that way, which there have been enough scandals about at this point for us all to know what's going on there, right? I don't need to explain that to you. So we can see that that's how AI is generally being used, and to have something that will basically give you the opportunity to introduce more varied data sets and create more useful algorithms that will be able to basically teach us new things, like be able to analyze data from healthcare or anything really, because it's suddenly wide open. It's not being like, we need to improve our marketing budget, or we need to improve our sales, or we need to be able to moderate this so that we don't have to anymore. It's actually giving it it's the work that needs to be done for the right kind of AIs, the AIs that we all think about. And if we don't get this fundamental work done, then it's going to be very hard to get to where we're thinking we need to go with it, or where we want to, where we imagine it going.
And in all my interactions with some of the medical community, it was not that they don't want to give you the data. It was always that, how will you guarantee me privacy? So that was because they are bound by law to protect the data that they have, and even if they want to monetize it, they cannot really do it because
they can't.
They can't. And think about it that we talk about some fancy things like, if I have my medical data, if I am here and I go to some other country, can I access that data? Can the doctor there access that data? Today it's not at all possible. Impossible.
You literally can't do it. You
just can't do it. And that's where I think some of the things that Riju is doing comes in handy, because now you own the data and you are authorizing that data. So Riju kind of helps you in that. And these kind of trustless environments can help you help the data providers with the guarantee that, hey, if I participate in this, it's not going to cause me any problems. So and that's where I have to invest a lot of time in this. I mean, and this whole thing will be open source. So, and no patents will be filed on this. It's all open source. People can review it. And tomorrow, when we take it to a stage where it can be used by real applications, then people have that confidence that, hey, you know what, this system works, and the code itself can be trusted because it's going open source. Then I'm also thinking that, if I end up doing a little more than the research part of it, then I will also try to get the contracts and everything audited, so that because you're dealing with some confidential data, then your solution should be backed by these kind of things, like your code is audited, your contracts are audited, and things like that. So that
it's just like helps. Working with the finances. You kind of owe it to users of your product that you have proven that it is safe or secure to be used, because there is obviously inherent risk in sharing data, just like there is sharing bank details.
Yeah.
So, PG, the idea here is to basically have something for we've been talking in the context of like health data, like your healthcare kind of stuff. But what could we do? Could we help you in a way that we wouldn't need to provide personal data? Is there some way that we can provide data sets that would enable you to do your work without it having to be something that as potentially risky as doing something like that, or as risky is the wrong word, but like confidential,
So I think there are some public data sets that are available. So I'm trying to use that. And then what I'm trying to prove with those public data sets is that indeed you can guarantee, you can think this.
You can prove the privacy aspects, you can prove the trustless aspect,
aspects of it. So I think, definitely in the first round, I cannot go take this to a healthcare provider and say, use it, right? I mean,
of course,
that would be foolish of me. So to do that. So I think where I will need help is in terms of getting this data. If you come across any data or any algorithm that you think can benefit with this kind of an environment, right? I mean, it's medical data is something which is an obvious
use case.
But
the thing about it is the end use case, isn't it? It's not the primary. It's not the initial use case of the. It's not the testing environment.
So there are many things where we can do this kind of training with non-sensitive data, but you still want to maintain privacy, say for whatever reasons. So we can try to include those kind of data in the later stages. But I think the initial stage, the whole goal is that you're doing so much of these things. You're putting a blockchain, you're putting all these layers, and you're saying that you're going to decentralize federated learning. Are you even doing better than that, or at least equal to what the federated learning is doing? I mean, there are classical machine learning problems, like you overfit the model or you underfit the model. And if the parties increase, like it's great for 3 parties, but what happens if suddenly there are 10 parties? Then what happens to your cryptographic proofs? What happens to auditability of the system? Will your proof size increase? Is it linear scale? Is it logarithmic scale? Or is it constant scale? So all these things have to be studied. It's not like
they're waiting to be discovered. PG, you better get to work. You got no time.
That's the whole exciting part of this, I would say.
I think this is like the non-sexy side of the work, but I wish that there was just something I could give you to help. I wish I could just I'd be like, here's a couple of data sets for you, but obviously if there is, let me know, but it's hard for me to imagine.
I think once I start getting with the testnet, maybe if you have some testnet nodes running, then I will talk to you, and a Cardano testnet plus a new net kind of a framework will be, I think, something that we can both work together on. Because I know you're in new net, so
I see. I can like as with this kind of stuff and with AI, I can see. I can picture it, you know, and I can be like, oh yeah, I see how that could be used with something. And for me, I just want to be involved in it. You know, that's how I became an SPO. Like I got into crypto, and then I was like, why am I just holding this stuff? Like, I want to do the building. I want to be the builder guy. You know, I want to be contributing. So that's kind of how it all started, and that's kind of my thinking in this journey. And I just want to be a part of all this amazing stuff that's going on. I've never been so fascinated by software and maths. You know, I just had never been that fascinated by it. And the more that I'm exposed to it, the more it just amazes me, which is like just crazy, even like compared to where I was like 5 years ago. Like it would have piqued my interest, but I would have never thought I would be as heavily immersed in the space, you know. And
I studied cryptography just from an academic perspective. I never thought I'm going to use cryptography in my real life.
And so for me, I'm coming at it thinking I need to use it for something, you know.
So it's kind of fun. And I would say that I tweeted that also, that 2021 was the most productive year of my entire life in terms of personal project space. I mean, I learned a bunch of new things, and and this Catalyst thing is just amazing for me. I mean, where else in the world can you take your idea, go to a place, talk about it, and then write about it, and then people go and comment about it, and then, you know, it's a nice feedback loop. And then hopefully,
and it all comes from instead of like you could do that on Reddit, right? But on Reddit, people are just going to overanalyze what you say. Whereas in Catalyst, the idea is like, how can we fund this? You know, how can we see if this is worth investing in? And I think that's amazing. It's a very positive atmosphere and environment for productive work. And I think that's really cool.
I think it's I just was surprised that this kind of system exists, and we can do a bunch of things. Initially, I thought my project will not be eligible for Catalyst, because Catalyst is looking for some things like, you know, as you said, right, you're building a DEX or you're building something like a DAO, and
it's the sexy side. It's the sexy side of crypto, isn't it? Like what a lot of people think, and that's what a lot of people get excited about.
And then I saw this Singularity Net track. I was thinking maybe, but still I was not sure. Then the Singularity Net folks said, hey, you know what? You should go out and write a proposal on this in Catalyst and give it in the Singularity Net space. And that's where I went and wrote that. And the other part is that until the Catalyst proposal, I was all by myself, in the sense I'm looking at it, I'm coding, I'm writing some document, I'm doing a video or something like that. Now I'm interacting with a bunch of people. Some of them are in SingularityNet, and then there are a couple of other proposals in SingularityNet which kind of have synergies around this. So it kind of it not only enabled you to bring out your ideas, but it also allowed you to collaborate with these people, right? Which probably I would have never done if it was not Catalyst.
And half of the issue of that is being exposed to those people, because a lot of these people are very hard to reach. You know, even if you're in the same community, they can still be difficult to get hold of. Like I found the same with my project. and in fact, just being part of NewNet or something like that, you get involved with one aspect of the community, and then you're drawn into another one, and then someone pulls you into the next one because they've seen you around, and they're like, you're coming, you're involved in this, and I think it's amazing. I've had the same experience with my projects. Like people, I've reached out to people to talk about it or to like present it in different places. And then people have come to me afterwards and been like, we need to talk. We need to try and figure this out, or maybe we can work together in some way. And it's great. It's great. I really hope that this comes to fruition, because I see it as being quite important personally.
Yeah.
Amazing.
Sure.
Well, listen, PG, I don't want to take up any more of your time because it's already been quite a while.
Yeah. More than 1.5 hours, I think.
I'll listen. I can just listen to you talking about this stuff and just yeah. So for me, I find it fascinating, but I appreciate your time, and I don't really want to just have you on here for ages, to be honest with you, mate. But we should definitely connect outside of here and talk more about this stuff. And in the NewNet community, in the ARM community, and Catalyst, or however, anything I can do to help you out with this, you just let me know, and I'll do whatever I can.
Sure. And same here. I'm very excited about the DAO project. So awesome. If I can be of any assistance, then definitely let me know.
Yeah, definitely. And actually, on the DAO subject, I've got some documentation and some ideas that I've been deep in thought of over Christmas regarding the rest of the Armada crew as well. So I think there's something there for us to have a little chat about outside of this as well.
Yeah, sure. Yeah.
Wicked. PG, man, thank you again for taking the time to come on and just talk to me about what you're up to and how it happened. Guys, I really urge you to learn about this stuff. Take the time to read through PG's Catalyst proposal, which is called Deepchain ADA.
Deepchain ADA. Trustless AI training.
Trustless AI training. Thanks, man. Thank you. Watch his videos on his YouTube channel. It's PGW ADA, isn't it? It's just ADA.
Yeah.
And check them out. He talks a lot about deep learning, how everything works, and how it can be applied with blockchain to kind of build out these concepts that he's talking about, that he's trying to research and develop, because they have amazing application if we can figure these things out. So I urge you to check it out. Voting starts very soon, guys. So Deepchain ADA, give it a good thumbs up and stick your vote in behind it, because it will help everything.
Thank you.
All right. PG, mate, thank you again. Is there anything else that I've missed, actually? Is there anything else that I haven't said that I should have, or that you should have?
I think we covered a bunch of things, I think. It's great. It's great.
I understand the whole purpose of the project a lot better now, just from listening to that. So thank you. Well, you look after yourself, mate. I'm going to end it up here. Guys, if you like what you've seen, as always, give us a like, subscribe for more Cardano videos every week, sign up to Catalyst, take part. This is like such a huge project that is on Cardano, just funding different elements of development like this and different projects within the Cardano ecosystem. It's really important to get involved. All right, guys. Thanks again, PG. Thanks for you guys who will turn it up. Check out PG, stake to PG. Thanks again for coming, man. And look after yourself. It was really nice having a call.